Good afternoon, everyone, and welcome to this webinar on Oracle EBS for closed loop manufacturing. Today's webinar will briefly touch on the following topics. Basically, we will go through an introduction of what closed loop manufacturing is, what are the key elements of closed loop manufacturing, and how can an organization obtain the visibility of their manufacturing processes. And potentially, we could also look at the industry compliance standards that are very popular and required for manufacturing organizations. Let's begin with what closed loop manufacturing is. Closed loop manufacturing, or CLM in its abbreviated form, is actually an advanced manufacturing process that integrates all the stages of manufacturing processes into a continuous feedback loop to enhance efficiency, quality, and sustainability. Now on the screen, we see the main key components of any manufacturing journey. We have the raw material that undergoes some form of processing to produce what we simply call a finished good, which might even be a semi-finished good, which is then put to some form of use in any form of industry that it finds use in. For each of these components, let's take a couple of minutes to just dive into those. Raw materials could be assemblies or components. Typically, these are the raw materials of a discrete manufacturing industry, automotive, mobile industries, and so on and so forth. Now, when the raw materials are ingredients or mixtures or raw materials that are converted into medicines or semi-solid components of pharma, medication, and so on and so forth, that form of manufacturing is commonly in Oracle parlance referred to as process manufacturing. A simple definition or differentiation between the two forms of manufacturing would be: in a discrete manufacturing, you could separate out the components at a later stage. Whereas in a process manufacturing, once the ingredients are combined to form either a finished or a semi-finished good, it is not possible for you or I to get the constituent components back in their original form. A very simplistic view of either a process or a discrete manufacturing. Process basically means any manufacturing activity or any activity undertaken on these raw materials, utilizing either equipment or labor, and there will be steps involved in converting the raw materials into different stages of change to make it finally available as a finished good. This could ideally also be components put together, assemblies put together, ultimately to result in the finished good. May I just request participants who are not on mute to please go on mute? Thank you. Right, once the processing is done, we have our finished goods, which are often either stocked in an organization, transported to wherever they need to be stocked, or even to their customer or vendor places, and so on and so forth, and sold, as the case may be. Again, this is a very simplistic understanding of what the components of a closed loop manufacturing is. And for use of these finished goods, it could either be internal or external use. Internal within the organization for reuse, recycling, whereas external, again, sell or distribute. Now, why is closed loop manufacturing important? Because as you can see, none of these circular components here are open-ended. They all interact with each other in an iterative, cyclical manner. That is, there is a continuous feedback, continuous exchange of information, a continuous understanding, a continuous flow of information between the different components to result in optimizing and ensuring that feedback is constantly received. So the four components of production, distribution, use, and recycle continuously interact with each other to result in what we call the closed loop manufacturing methodology. So the core idea of closed loop manufacturing is to create a seamless flow of information and materials from the initial design phase through to production, distribution, use, and recycling or disposal. So what happens is in this methodology, we can ensure that the data collected at each stage is used by organizations or process teams, compliance or quality teams to inform and optimize the next stage. Costing, continuous improvement, and minimizing waste at each stage. Closed loop manufacturing thus means that the materials used in production can be reused. Closing the loop thus ensures that any post-consumer waste is collected again and reused to restart the process all over again. So what happens is instead of a straight line movement from material to production to purchase to landfill, closed loop manufacturing ensures that these products aren't just used once. They are used over and over and over again. This is good news for potentially the environment, for potentially organizations, for anyone seeking to adopt sustainability, adopt cost-saving mechanisms, any organization that looks with a future thinking in mind. To achieve these, the key elements of a closed-loop manufacturing system would be, first of all, integration of their IT systems. Every organization now depends on multiple systems like ERP systems, MES systems, PLM systems, other enterprise systems. Integrating all these systems together to ensure seamless data flow and communication is one of the key elements of closed-loop manufacturing. Another key element is the real-time data collection. Utilizing IoT devices and sensors to gather real-time data on equipment performance, product quality, and other critical parameters is another key element, ensuring that closed-loop manufacturing offers up to its capabilities. Combine this with advanced analytics and AI ensures that employing big data analytics and AI to process the collected data, identify patterns, and predict issues will help improve and optimize processes at every stage of the manufacturing process. So the dependency is not on ad hoc or random quality checks. The dependency is not on when a process is completed or when there is an issue identified. Instead, organizations can follow a more proactive approach rather than a reactive approach. Feedback mechanisms. Implementing mechanisms to provide continuous feedback from the end users and downstream processes back to the design and production stages will also help with optimizing production processes. As I mentioned earlier, incorporating recycling and reusability into the product lifecycle ensures that we take care to reduce the environmental impact of the production processes as well as the products created on the environment. The last key element would be collaborative platforms. Using collaborative platforms will enable communication and coordination among the different departments and stakeholders to ensure that the focus and the vision of closed-loop manufacturing and the ultimate aim of closed-loop manufacturing is continuously realized. That is, being informed, optimizing, improving all those key tenets of closed-loop manufacturing is at all times adhered to. For an organization to see how these key elements of closed-loop manufacturing will work together, as I mentioned, organizations will be using MES systems, smart devices, or IoT devices and sensors across different equipment to monitor what is happening on the ground or on the shop floor. Implementing MES, manufacturing execution systems, provides a real-time visibility into the manufacturing processes. We can track production status, we can track quality of production, we can track the performance of production utilizing MES systems. IoT and smart devices can monitor and report on machinery, environmental conditions, and product quality in real time. Data interpretation and insights can help organizations arrive at trends, the collected information. Ensuring a seamless integration between ERP, MES, and other systems will help provide a comprehensive view of the manufacturing process. Now, leveraging analytics tools helps organizations and production teams to interpret data, identify trends, and generate any actionable insights, which will impact their production efficiency. Creating a digital replica of the manufacturing process to simulate, analyze, and optimize production in real time is another key way an organization can obtain visibility into their manufacturing process. With traditional manufacturing processes, there is a tendency to rely on increased quality inspections. This is typically not good enough to adequately reduce risk of error. As James B. Thompson says, you can't inspect quality and reliability into a product. Manufacturers need a more holistic and systematic approach to fully address a product's risk. A digital enterprise approach gives manufacturers that holistic and systematic method to deal with challenges and achieve an integrated product lifecycle. This is achieved through the digital twin technology, a digital model of the manufacturing process and the product. This digital twin technology establishes the foundation for continuous improvement and change, and closed-loop manufacturing is a key element of this approach. Closed-loop manufacturing seeks to increase efficiency in resource usage and data flow throughout the production line. It promotes a faster flow of information that is aimed at increasing the quality of products and production efficiency. One industry where an error on the shop floor can be very costly to people's lives is the medical device industry. Closed-loop manufacturing, using continuous information flow to improve and optimize product and production efficiency, is critical in the medical device industry, an industry that works under a strict regulatory framework. Dashboards and KPIs and other reporting tools can be utilized to visualize the data and monitor any key performance indicators that can decide changes in processes, changes in approach to improve an organization's manufacturing capacities. With regards to Oracle EBS, which is the focus of our webinar today, these key ways in which the visibility of the manufacturing process in an organization can be obtained is by utilizing different modules of the manufacturing suite within Oracle eBusiness Suite. Now, within Oracle eBusiness Suite, as we mentioned earlier, there is support for both discrete as well as process manufacturing disciplines, two separate suites for the same. Discrete manufacturing dealing with discrete manufacturing like automotive manufacturing capabilities, whereas process manufacturing, Oracle EBS process manufacturing modules deal with manufacturing for pharma, medical, those kind of industries, chemical industries, and so on and so forth. Supported by other modules like quality management, advanced supply chain planning, and the supply chain management and financial modules. These modules work in conjunction with each other to provide key integrated insights into the digital twin of an organization's manufacturing journey. For each of these modules within EBS, enterprise command centers that provide key dashboard views, insights, KPIs, which are important to the various roles embedded within each module, are also available for use out of the box. For any organization that is involved in manufacturing, closed loop manufacturing is a key tenet focusing on continuous improvement and feedback. And this is important because it ensures that your manufacturing processes are clearly understood. There is clear feedback at each stage of the process. And at each stage, improvement and optimization can be built in to ensure that your production process runs like a well-oiled machine. I will just take a look at the chat to see if there are any questions. So this is about future sessions. All right. In keeping with statutory compliance, now closed loop manufacturing is intended to improve every organization's manufacturing process.
Hello, Elizabeth.
Yes, please.
Yeah, I mentioned that can you go to previous screen? Yeah, in this EBS discrete manufacturing, so you can track means we can barcode scan use scan barcode scanning also and resource scanning. All these things will happen.
Barcode scanning, you are looking at which stage, madam? Is it at the time of finished goods or is it at the time of raw materials? Or because barcode scanning is a key availability of supply chain, not just in discrete manufacturing.
No, for discrete manufacturing, when we are issuing the material, we want to use the material through scanner.
Oh,
so
yes.
This I want. So
yes, it is doable. It is entirely doable that you can issue out or receive material using barcode. So you want to be able to uniquely move your material using barcodes. That is easily supported.
And along with routing also, routing means it will manage the routing steps accordingly, right?
This is for issuing onto the shop floor?
Yeah, as per routing.
Yes. So issue onto the shop floor in discrete manufacturing will always be against the routing. Just as in process, it will be against a formula.
Yes.
Issue onto the manufacturing floor will always be against the routing.
Okay.
And in case you would like to reroute, you can potentially consider a workflow or an approval mechanism in case there is going to be a deviation. An approved deviation plan also is recommended and followed by some manufacturing organizations.
Okay. And in EBS discrete manufacturing, through this, we can also calculate the resource utilization.
Absolutely. In manufacturing modules of EBS, as you rightly mentioned, resource can, as you know, can be both labor as well as equipment. Now, when you assign them to any job or match, both of these are the cases in discrete and process manufacturing respectively, the actual utilization, you can have predefined based on your routing and formula. And when actual execution happens, you will see the actual utilization of your resources.
You.
So let me go forward to the different compliances and certifications that manufacturing organizations typically look at. One of them is ISO 9001, which is ISO 9001 for quality management systems. This certification basically sets out the criteria for a quality management system for any organization. to ensure that products and services from an organization consistently meet customer and regulatory requirements. Now, this ensures that every organization that claims or offers services and products continuously updates themselves to ensure that they are meeting all the regulatory compliances. ISO 14001, Environmental Management Systems, provides a framework for an effective environmental management system. This will help organizations to improve their environmental performance. One key tenet of closed-loop manufacturing is its focus on sustainability and reuse, recycle fundamental tenet, which ensures that we try to reuse and recycle all of the components used in the manufacturing process. So this came about because there was a need to take care of how we can minimize our negative impact on our environment. So just as we often emphasize that it is each one's responsibility, every organization also understands that it is their responsibility to do the same. One certification that helps organizations with regulatory compliance for the same is ISO 14001. ISO 45001, Occupational Health and Safety Management Systems, specifies the requirements for an occupational health and safety management system for every organization to adhere to. This is key to improve employee safety, reduce workplace risks, and create safer working conditions. ISO TS 16949 for automotive quality management system standards. This aligns existing American, German, French, and Italian automotive quality standards within the global automotive industry. As with any standards that are, like the ones that are mentioned on the screen, there are several standards across the globe in different regions. There are standards specific to different industries as well. These standards and benchmarks and compliances or statutory compliances have come about as a result of a lot of thought and research into what makes the safest and best practice that can be followed by every industry to ensure both quality of product, quality of production, methodology, and safety of resources or safety of the workers. So taking these three factors into consideration, these certifications often are utilized by organizations to achieve the optimum performance for all three cases. Good manufacturing practice certificate ensures that the products are consistently produced and controlled according to quality standards. And this is commonly applied in pharmaceuticals and food production industries. ROHS, restriction of hazardous substances. This certificate or the tag of ROHS compliant ensures that this organization restricts the use of specific hazardous materials found in electrical or electronic products to ensure safe disposal and recycling of their products. REACH is another certificate, registration, evaluation, authorization, and restriction of chemicals. This addresses the production and use of chemical substances and their potential impacts on human health and the environment. I'm sure we have all often seen the BPA, no BPA stickers on a lot of the things that we see nowadays. So those is another example of that. FDA regulations for manufacturers of food, drugs, and medical devices, ensuring their products are safe and effective for public use is achieved by ensuring that they have complied with FDA regulations. These compliance standards help manufacturers ensure that their processes and products meet quality, safety, and environmental requirements, ensuring that this will help to foster greater trust and reliability in the market. That was a brief overview of closed-loop manufacturing. Before I leave you today, I'd be happy to answer any questions that you have. We'd also like you to have a look at our ECC Enterprise Command Center webinars that are there on our YouTube channel. We have 4 webinars. The first one was an introduction to the enterprise command centers. Second, third, and fourth webinars were about supply chain, finance, and manufacturing dashboards. They dived deep into those dashboards and the capabilities of the same. And these dashboards are available at no additional license cost for EBS customers. So for any further questions, do reach out to us at the addresses mentioned on the screen. And if there are any questions right now, I'd be happy to take them on this call.
There was a question that I can see from Rushi Patel, that how NCRs are managed from feedback mechanism in a closed loop manufacturing scenario. If you allow me, I'll try to answer that, because this carries, goes to one of the examples that we could do in Al-Raji Pharmaceuticals. See, when when we are using closed loop manufacturing to automatically record the production which is happening. So in a typical situation where in one of the customer place where they used to manufacture some drugs, and based on that drugs it used to fill the particular bottles, and based on these bottles it used to declare the production. So they used to have something as a like a wind resistant wind load testing. One blower is there. So when the manufacturing will happen, and those sequences which is blown away will be automatically given a feed through one of the scanning device, and based on that the production declaration will say that these are the sequences which has not been has completed the finished good, and that will get recorded into the production closed loop manufacturing production declaring batch declaration process. I just wanted to cite an example. I think we can write to him back, and any other questions if you have, you can put drop down your queries, and then we will send a mail to you based on the answers.
Sorry guys, it's Rushi here. It's night here. I can hear you, Rajiv. That's all good. But yeah, good to know for the example.
Yeah, thank you so much. And more details, we can drop you a message, and we can.
Yeah. I was more interested in the NCRs when you trigger something from your system using IoT devices, and it will trigger the NCRs. Is it going to like that particular batch will be rejected, or what? How the things? I'll take it offline with you. No rush right now.
If you allow me, I'll give you in 2-3 lines. Point number one is that the typical example that we are trying to say that when this some medicine bottles are generated, there is a serial number which has to be serialized. So when the production will start and the serialization will happen. But because of NCR, like as I said, there is a blow testing machine which will blow it, and because of the blow, if the weight is less, then it will be blown away, which means that particular medicine box is rejected. And after that, when it moves forward, there is a scanner which keep on scanning the number of sequence which is generated. So based on this, the one which has been missed out will be recorded, and it will go back to the batch declaration, and we know that only this number of sequences serialization was successful, and the rest one was rejected. So automatically that will get recorded. So that
that's good. And are you using quality plan in there?
Yes, we will. There will be a quality plan on declaration part of it, like the batch closing, batch completion. You can have that quality sample generated in the pharmaceutical. It is in process manufacturing. So when the
because I have been working in healthcare for last 20 years, so that's why I was more interested in NCRs.
If you can drop me the message, I will pick your email ID and I'll
take you offline. Yeah. Maybe not now. It's night for me here, but we'll take it on Monday.
Okay, thank you so much. Thanks.
So if there are no other
That's
questions, thank you, Shainesh. Thank you for that clarity. I think it helped everybody understand and put into perspective what we discussed today. Right, so thank you everyone for your time on today's webinar, and we look forward to having you join us on our next webinars. Stay tuned and do reach out to us with any questions you might have. Thank you.
Thank you, everyone. Thanks. It was very good one.
Thank you.
Bye.
Thank you.